When you are finally going into commercial production, you have to guarantee a constant quality. So in order to do that, the selectivity of the reactions has to be the same. It has to be a very robust process. You also have to understand the chemical and physical stability of, for example, the intermediates of the synthesis. How long can you store them? That's important. Do you need refrigerated conditions to store them? This is certainly the case for the active itself. So specific stability tests are being set up, running over 24, 36 months. And depending on where the compound will be marketed, these are running under different conditions, at 30 degrees, at 40 degrees, different relative humidity as well, up to 75% relative humidity. So that's part of the control strategy, making sure that the active really can be stored under stable conditions where we don't see degradants. Another aspect that to guarantee that control quality, we built in a number of purification points in the synthesis. Certainly the final step itself, but there could be also intermediate purification points. Part of the control strategy is also that when we submit a file to authorities, the steps are what we call post the registered starting material are described in full detail, including parameters, for example, settings of temperatures, stirring times, and obviously we cannot deviate from that. So it's registered in the filing. Every time we reproduce a new batch, we have to stay within these filed limits. So that's part of the control strategy. The processes before they are marketed are also validated. So you run a number of batches within preset criteria that in advance you say that these are the criteria we want to meet. These are the settings we will use, and we will run a number of batches, and they have then to obtain a certain preset quality as well. The final product itself, the API, is controlled not only for organic impurities, but also for example, residual solvents. There are specific guidelines, what we call ICH guidelines, which have been met for every API. And also, for example, for metals, specifically heavy metals, there are specific guidelines that we have to meet. There have been several initiatives, and some of you might have heard about quality by design. So it's really to understand the processes that are being used. For example, design of experiments is used there to check parameter combinations. If you have a certain time with a certain temperature, are we still meeting the expected quality? And we are also defining normal operating ranges and proven acceptable ranges. So the proven acceptable ranges, this means if you go beyond that, that you are almost at the edge of failure of your process. And obviously the acceptable ranges are more broader than the normal operating ranges. So what are the typical levels that are allowed in the final product? It depends on the dosage, but let's say for most products which are dosed less than 2 grams a day, you can specify impurities if you have demonstrated with specific tox studies that these levels are allowed. But typically we have to report every level that's higher than 0.05%, and we have to identify the structure of every compound that's present above 0.10% in the active itself. I was referring to genotoxic impurities. They have to meet different levels. So for commercial products, that's 1.5 micrograms a day, which is, for example, if you have 2 times 750 milligrams a tablet, 1.5 gram a day, it means that these specific impurities have to be below 1 ppm for that product. This is, I would say, that concern has been raised and increasing over the past 6-7 years, and certainly led to the fact that quite a number of, for example, sensitive analytical methods have to be developed for our APIs, just to make sure that we don't have these potentially genotoxic impurities in there. For example, if you are making an HCl salt in ethanol, you might not be aware of that, but you can be sure that there will be ppm levels of ethyl chloride, which is a genotoxic compound, if you have not very carefully designed your process. So it's an additional criterion. I would say it has certainly generated some additional development work, analytical work, to make sure that we can meet this very low levels of potentially genotoxic